With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question here says, assertion is given, solubility of alkali earth metal carbonates decreases down the group. Now reason is, hydration enthalpy decreases down the group whereas the lattice enthalpy remains constant. So we will see which option is correct, true or false, and according to that we will choose the options. So in first option it is told, we are talking here about the solubility of alkali earth metal carbonates. So what are basically alkali earth metals? They are beryllium, magnesium, calcium, strontium, barium and radium. These are known as the alkali earth metal. Now the carbonate, what is carbonate group? This is CO3 2- is known as carbonate group. Now as we know that as we move down the group, the size of the atom increases. Now if the size of atom increases, then their cation size also increases, right? Size increases. Now if the size of their cation is increasing, then with the increase in their cationic size, their charge density also increases. Charge density, this is charge density, also increases. Now we know that as the charge density increases, the hydration energy also increases. Now what is hydration energy? This is the energy released when one mole of water molecule is attached to the group. So this is hydration energy. So we know that there is a relation between our hydration energy and charge, that is hydration energy is directly proportional to charge density. Now what is directly proportional? That if the left hand side value would increase, then the right hand side value would also increase. Now as told in question, we will read that solubility of alkali earth metal carbonates decreases down the group. Now they are talking about that the hydration energy decreases. So we will see one thing, that as the beryllium, magnesium, calcium, strontium, barium and radium would change into their cationic form, it would be like beryllium 2+. Okay, because the outermost electronic configuration is outermost valence shell has 2 electrons, so we are taking here barium 2+. Now barium 2+ would have a charge by size ratio. Charge by size ratio would be charge as is equal to +2 in every element, or every element over here in the group, in the alkali earth metal group, but the size would increase as going down the group. So suppose for beryllium it is a small, then the value would come as, if 2 is divided by a small quantity, then a relatively larger quantity is received. But suppose that it's for magnesium 2+, then as we know charge is same, that is 2+. Now the size is large as compared to that, and if any constant values or any fixed value is divided by a larger quantity, then the ratio decreases. So we can say relatively smaller value. So by this trend only we can see that the value would decrease as going down the group. So we can say charge by size ratio, which could also define the charge density, decreases down the group. And from this relation we can see that as the charge density would decrease, the hydration energy would also decrease. So because of this only, our first option is true. What they are saying is that the solubility of alkali earth metal carbonates decrease down the group. Yes, that is true. It would decrease down the group because the hydration energy decreases. Now the second option, that is our hydration enthalpy decreases down the group, whereas lattice enthalpy remains almost constant. Okay, now we will see the second second reason that what they are telling. They are here talking about the lattice energy. They are talking about lattice energy. So basically lattice energy is the energy that is released when a molecule or 1 mole of a solid substance is converted into its gaseous state. So that is known as the lattice energy, and lattice energy basically depends on the charge of the ion. Second, it also depends on the radius of the ion, and also it depends on the, or we can say radius or size. It's approximately same only, radius or the size. So as we have seen in the above that hydration energy decreases down the group. Now one more thing we know, that as in the first statement we have seen that the hydration energy decreases down the group, as well as the size of the ion or the atom increases down the group. Okay, so as told that lattice energy, here I am writing the conclusion what we have seen, that in group means going down the group. Okay, hydration energy increases, hydration energy decreases. It's not increases, it's decreases. It decreases. Here it would be decreases. Hydration energy decreases, as well as the size increases. Okay, so we know that now with the size we can say that the charge is constant, is equals to constant, because in down a group there is same ionization of the group, that is +2. They will donate only 2 electrons. So as seen in the lattice energies definition, that it depends on the charge, radius and size. So in group 2 or in alkali earth metals, we see that the charge present on the whole group is constant, that is 2. Charge is constant, that is equals to +2. So as told that lattice energy depends on charge, size and radius. So if the charge is constant, then definitely the lattice energy would also be constant. So second option given above is, here it is given that hydration energy decreases down the group, that is true, whereas lattice enthalpy remains almost constant. Yes, that is also true. So our option number second is correct. Sorry, not option number second, because here it is said in both assertion and reason are true, and the reason is not the correct explanation for assertion, but no, here the reason is correct explanation for the assertion. So our option first is correct. Here it is a little bit confusing that assertion, reason both are said true in both the options, but what differentiates between option 1 and 2 is the relation between the assertion and the reason. So they both are right. So the reason is correct explanation for the assertion. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.